All right, let's take a look at an example using compound interest and using this compound interest formula. I have it here again so you can look at it as we are trying to figure out what numbers need to go where. So this problem says, find the amount owed at the end of 7 years if $2,000 is loaned at a rate of 5% compounded quarterly. So we know that 7 years, that's our time. So t equals 7. This is our start amount because that's the amount of money that was started to be loaned. So that's going to be our principal. So P equals $2,000. Our interest rate this time is 5%. Written as a decimal, that would be 0.05. And compounded quarterly, that means n equals 4. So now we're going to use this compound interest formula and replace those values with the variables that are there. All right, and we put those numbers in. This is what we have. So A of 7, remember we said our time is 7 years. So that's what we're trying to figure out, is what that end amount will be, or that future value, after 7 years. So now we can go ahead and simplify here. Put in your calculator 0.05 divided by 4, and then add 1 to that. So we'll have 2,000 times 1.0125, all raised to the 28th power, because 4 times 7 is 28. Now we need to raise this to the 28th power. All right, so that is going to give us this decimal of 1.41599923. And again, that keeps going and going and going. Keep that whole number in your calculator and then multiply it by 2,000. So that will give us $2,831.98. And this is going to be the amount that will be owed in 7 years. So what if the same loan was instead compounded yearly? So everything's going to stay the same on there, except that instead of compounding it 4 times a year, it's going to be compounded once a year. All right, so notice that when we take our rate and we divide it by 1, because now our n is 1, that's just going to give us our rate. And also, if we look at our exponent, we're going to have 1 times the time. Well, 1 times the time is just going to give us that time back. So this is what our equation is going to look like. So let's add our 1 to our 0.05, then raise it to the 7th power, and times it by 2,000. Pause your video right here, work it out on your calculator, and see if you come up with the right answer. All right, so remember on part A, it was also 7 years, but compounded quarterly. So we came up with $2,831.98. And now, if it's compounded only once a year, it looks like we owe a little bit less. All right, what happens if we compound it daily? How is that going to change our answer? All right, so now compounded daily, remember our n for that would be 365. So now when I fill it in here, I'll see my n there is 365, and my n up in the exponent is also 365. Now, 7 times 365, let's figure that out first, and that is 2,555. And now, in your calculator, start with this fraction, 0.05 divided by 365. Keep that number in your calculator, add 1 to it, then take that whole thing and raise it to the 2,555 power. After that, times it by 2,000. Go ahead and pause your video again, work it out on your calculator and see what you get. Right, did you get $2,838.07? Again, as we're comparing these, we can see they're all pretty close, but this one we're owing a little bit more than what we did if we're compounding it quarterly. Well, if we compound it monthly, we could probably guess that our answer would be somewhere in between 2,831 and 2,838. Let's go ahead and see what that would be compounded monthly. Our n for that this time is 12 because there's 12 months in a year. So putting those numbers in, this is what we get. Again, just our n is changing. So we're dividing the 0.05 by 12, and in our exponent we have 12 times 7. So let's replace that 12 times 7. 12 times 7 is 84. Now go ahead and do this again. 0.05 divided by 12, add 1 to it, raise that to the 84th power, and then multiply it by 2,000. Did you come up with $2,836.07? Well, that's what we were guessing it was going to be, because if this is compounded quarterly, so 4 times a year, and this is compounded 365 days a year, monthly would be somewhere in between there. So that is what we were thinking we were going to get.